This video is about the remove useless attributes operator. This operator removes attributes which are deemed to be of no value, so can be removed. For example, when you're classifying, an attribute that has the same value for all of the examples will not affect the classification and so can be removed. We'll cover parameter details about the numerical min deviation parameter, the nominal useless above and nominal useless below, and then finally the nominal remove ID like parameter. So let's look at a process I've created for this. Again, I've created some data. Details are not important for this video. And then I've simply had a single remove useless attributes operator with various parameters. So I might as well just run this so we can get straight on with the data. So the data I'm basing this on is the iris data set with some renaming. And so this is the raw iris data set, and what I've done is added some new attributes. And if you see here, I'm clicking on the result view here, and you can see I've added a number of attributes. If we look at the statistics view, you can get a sense of them, and the names are sort of a giveaway as to what status these are. So I've added 1, 2, 3, 4, 5, 6 new attributes. So as you can see, there's an attribute called useless number, which has, as you can probably tell from the view here, it's basically the same value for all examples because its deviation is 0 and its minimum and maximum and average are all the same. Then there's another numerical value here which I've called possibly useless. So this has an average of nearly 100 and a minimum and maximum really quite close to 100 and a small deviation around that point. So this attribute looks like it perhaps doesn't vary very much. So let's deal with these two first and see how we could eliminate those using the remove useless attributes operator. So if we go back to the design view, if I click on the operator here, if you look over here, there is, I'll move this over a bit, if you see here the parameter numerical mean deviation is what you can use to control whether an attribute is removed or not. So in this situation I've set that to 0.3. The default is 0. I've changed it to 0.3. So if I go back to the results view, the useless number, its deviation is 0. So the default for the operator and the setting I've set the one to in this will cause this attribute to be removed. Because I happen to know that the deviation is 0.293 for this one called possibly useless number, you can see that because I've set the parameter to 0.3, that is greater than the 0.293, so the deviation is less than 0.3 for this attribute. So this will cause this attribute to be eliminated from the final result. So if I click on this tab here, you can see that it's disappeared. And to prove that perhaps I'm not pulling a rabbit out of the hat, as it were, that is the example connection from the remove useless attributes operator. I'll run it to prove it again. So I've clicked on the final output from that, and you can see the attribute here has disappeared. Not only has the useless numeric attribute, but the possibly useless has disappeared as well. So if I go back to the design view, I can change this to 0.2. If I do that, what will happen now is that the possibly useless attribute will turn up. Okay, so let me go back to the set that back to 0.3. Okay, so that sort of shows how straightforward it is. Now the default for this operator is the deviation is 0, so basically all constant numbers are just automatically eliminated, and generally that's perfectly okay. So that's a very good step actually to use, but what I'm showing here is a little bit more sophistication. Now an important point about this is the normalization of the attribute. Now it's extremely important that you take that into account. So clearly if I look at the statistics view of each of these numbers, if I were to set the min deviation to 0.45 say, then the sepal width would be eliminated as well. Let's just do that to prove it. So I've done that now, and sure enough, if I go over to here, the sepal width attribute has been deleted because it's deemed to be an insufficient variation to be relevant to the prediction that perhaps we're trying to make. So it's extremely important, therefore, that you get the range of the numerical attributes consistent with one another, so that you don't accidentally eliminate some large attribute that still happens to have a large deviation by virtue of it being a large number in the first place. So I'll set this all back to point 3, where I started, and run it again. Then we'll next look at the nominal attributes. So let's just refresh our memories about this. So again, I've got an attribute here called useless nominal, and you can see the hints in the name really, but it's basically one value, and it's called useless, and it only exists. That's the only value. So this can have no possible predictive power. So there's no point keeping this. But I've also added some others. I've got a one frequent nominal, and what this has, out of the 150 examples, there are basically two possible values. One occurs 140 times and the other occurs 10 times. I've also added an attribute called many nominals, and this has, you can probably see, there are 10 possible values, and the most frequent one occurs 24 times and the least frequent one occurs 7 times. So if I want to eliminate all of these three, useless, one frequent and many nominals, I have to set the parameters up in a certain way. So basically what you have to do is you have to decide how frequent an attribute has to be before it becomes irrelevant. So this is what this parameter rather, is doing here. Nominal useless above 0.9. Think of that as percentage. 90% is 0.9. This is saying that if the most frequent value in the nominal attribute occurs in more than 90% of the examples, then that attribute is not, or is unlikely to be predictive of the final thing you're trying to predict. Hence, you might as well remove it. You might as well regard that attribute as useless and remove it. So setting this to 0.9 will have the effect of eliminating the attribute called one frequent nominal, simply because 140 out of 150 is well over 90% of the total. Therefore, that attribute is regarded as useless. Hence, it goes. The other end of this is the nominal useless below parameter. So this is set to 0.2. So think of this as 20%. So in other words, if the most frequent value of a nominal attribute appears in fewer than 20% of the examples, again, that probably means there are a lot of potential different values for that attribute. Therefore, the attribute is unlikely to be predictive of a class in a classification problem. So therefore it's useless, so therefore let's delete it. So if we look at the sort of way the data is, and in here is many nominals, so again the most frequent is 24 out of 150, which is less than 20%. Therefore this would be eliminated. So therefore if I run that, that's what happens. But there's also the ID-like attribute. If I go back to the results view, again you can see here there's an ID-like nominal. All this really is just a copy of the ID. So that each row in the example set has a different value for this ID-like nominal. There's absolutely no way that can be predictive of the final class. So essentially that's a special case really of the 0.2 nominal useless below. We'll come in a minute to the nominal remove ID-like parameter, but essentially this 0.2 will encompass an ID-like attribute. So therefore, if I run that, this is exactly what you would predict. You would see that the original attributes that were in the original example set have been allowed through, but all of the ones I added, the useless ones and the possibly useless ones and these nominal variations, have all been eliminated. But we might as well just check this box here, the nominal remove ID-like. So this essentially removes the nominal useless below option, and now all it really does, it looks at nominal values and it says if it looks as though every single one is different for every example within the example set, it's an ID. So let's just delete it. If I run that now, what you'll see is a subtly different thing, that the many nominals attribute now is more common than the rule to exclude it, so therefore it appears. So again, the ID has disappeared. If you look here, this ID like nominal column has disappeared, but now the many nominal attribute is sufficiently variable, insufficiently unvariable. I can't quite think of the right way to put it, but it's not an ID, so therefore it doesn't get removed. You know, it's not different for every example in the example set. So one final, let's just run this all again with the nominal ID unchecked. So again, just as the final summary, here's the input to the remove useless attributes, here's the output.